All right, we are going to talk about discontinuities. So in this last section of characteristics of graphs, we're going to go through the three different types of discontinuities that you can experience or have in a graph, and then how to identify them and label them or name them. Okay, so for example, the first type of discontinuity you can have would be a removable discontinuity, also known as a hole. And up here, that's anywhere in your graph that has a piece that seems to have been pulled out or removed. So this is a removable discontinuity. And then so is this one, because the graph goes and continues straight through that point, but it looks like you just removed one piece of it. You could either remove the piece and then it's just gone forever, so remove that one point and then it doesn't exist anywhere else, or you could remove it and it could be somewhere else. So like there's a removable discontinuity here because your graph has a point removed, but that point exists up here instead. So those are both examples of removable discontinuities. And we would say for these ones that we have removables that exist at x equals 2, that's at this point right here, and then at x equals -1. So that's how you would label where a removable discontinuity exists, and then that's how you identify them by the holes. Okay, those are different from what would be considered your jump discontinuities, which would be the next one. And a jump discontinuity occurs anywhere that your graph seems to stop at one place or one y value and then pick up somewhere else. So this is an example of a jump discontinuity because my graph continued up until this point, and then it boop, jumped down here, and then it kept going. So we would say that we had a jump discontinuity at x equals 0. And then last but not least, we do have to do a real quick labeling on your graph. So if you could go ahead and slap some dotted vertical lines down here for me. This is what we call an infinite discontinuity. Or you also might have heard it been called a vertical asymptote. Okay, we see these a lot in rational functions. So we would say that we have an infinite discontinuity where x equals 5. All right, excellent. So those are the different types of discontinuities you'll be expected to identify and tell me where they exist at. And remember, you're just telling me x equals and then whatever x value it happens at. You're not listing points or intervals or anything like that. Just there is a removable discontinuity at x equals -1 and 2. There is a jump discontinuity at x equals 0, and there is, a removable discontinuity at x equals 5. The other thing you could be expected to do would be to draw two different functions that fit certain discontinuities. So for example, on this graph, I'm going to zoom in a little bit more, we're going to draw two different functions, one with a removable discontinuity at x equals -4, an infinite discontinuity, at x equals 2, and a jump discontinuity at x equals 6. So I'm actually going to draw those discontinuities in right away and then put graph in between them. So at x equals -4, I have a removable discontinuity. So I'm just anywhere on -4 I can do it. So I'll just put a hole right here, and I'll graph coming off of it. And then you could place the point somewhere else, but you don't have to. I have to have an infinite discontinuity at x equals 2, so that's easy because I'll have a vertical asymptote there. And then a jump discontinuity at x equals 6, so then I can have a graph that jumps from here to here. And we'll make it go this way and then go this way. Okay, now the other important part about this is that you have to draw a function, so make sure it passes the vertical line test when you're done at the end. Okay, so I'm just going to have this graph just go off to the side. That's fine, you can go over there. This one is going to get really close to my vertical asymptote because that's what an asymptote is. It approaches but never touches it. And then I'm going to say my graph came back down from that asymptote and joined up with that jump discontinuity down here, and it goes that way for forever. Okay, so that's an example of a graph which has a removable, an infinite, and then a jump at 6. And I'm going to do the same thing over here, but this time I'm going to make sure my graph at the end looks different than this one. So for example, my infinite can't really change, so I still need an asymptote here. But my removable, instead I could put a removable hole up there, and then I could add a point, right? So I could take the piece that I removed and put it somewhere else, but I still have to have a hole. And then for my jump, well, let's make it almost like it almost got really close together. I'll put my jump down here. But this time I'll have it coming on that side and then going on this side. All right, so let's do, oh, here, we'll make it constant this way. And then we can do some fun squigglies or something like that, right? And then it goes down. Wow. Let's make it fun squigglies. And then down forever. Oh, geez. Hold on. We got this. Fun squigglies. And then down forever. Down. You know what? I give up. We're just going to go down. Apparently the squiggles were too much for me. And then, let's see, we'll have it come from above again. Oops. I'll have it do one squiggle. There you go. Yes, perfect. I got a squiggle in there. And then this one will just go that way. Perfect. So that's a graph that, again, it has a removable at x equals -4, a vertical asymptote or an infinite discontinuity at 2. Oh, this probably needs an arrow. And then a jump at 6. But my graphs look completely different, and they both pass the vertical line test. Is the last thing you should always check if you're drawing. If I draw a vertical line anywhere through here, I only ever hit my graph at one point, right? Even at my jump, I'm okay. Same thing with this side. My vertical lines, vertical lines, vertical lines. That's why I was being so picky earlier about my squiggles. Cool. All right, so those are the types of discontinuities you'll be expected to recognize and draw examples of and identify where they're at. Let me know if you have any questions.